Good day everyone. So for this presentation, I'm going to talk about tannin and tannin containing derivatives specific for ferric chloride test. So the principle of this test is that it is utilized or conducted to determine the presence or absence of tannins and phenol in a given sample. A ferric chloride solution is a test for phenols as they form intensely colored complexes with ferric chloride, which is often dark blue as the indicator of positive result. Some carbonyl compounds with high phenol content can give false positives with this test. So for our samples, we utilize the assigned sample X to us, which is malunggay, and together with guava leaves and bark. For the actual results, we can see here in the photo that sample X or malunggay emitted or shown a dark or black colored solution. So what we can deduce from this, this means that, or this indicates that there is presence of tannins in our sample X. Moving to guava leaves and bark, they both showed a dark colored solution, and this suggests also that there is presence of tannins in bayabas, leaves, and barks. So what we can conclude from this? Our samples tested positive because there is presence of tannins in them, which reacted with ferric ions in our ferric chloride test. The positive result obtained in this test is characterized by distinctive color changes as shown earlier, indicating the presence of tannin-rich compounds in the samples utilized such as bayabas and malunggay, and this aligned with the studies emphasizing the specificity of this test for tannin detection. These findings underscore the potential applications of the tested samples in various industries due to their antioxidant, antimicrobial, and astringent properties, highlighting the significance of tannins in health and industrial sectors and prompting further research and exploration to their uses.
The principle of the potassium ferricyanide test for tannin and tannin-containing derivatives involves the reaction of tannins with potassium ferricyanide to form a blue-colored complex due to the reduction of ferricyanide ion to the ferrocyanide ion. This reaction is characteristic of tannins and is used as a qualitative test to detect the presence of tannins in a sample. The expected result in this test is blue, black, or dark green complex. However, both our sample X, which is malunggay, and the guava yielded a negative result, forming brown solution and yellowish-brown solution respectively. This implies that there is no too little amount of tannin reacted with potassium ferricyanide. For the conclusion, the sample did not produce a blue complex with potassium ferricyanide despite containing tannins due to various reasons. The specific tannin composition may not react effectively with potassium ferricyanide, and the presence of other compounds like flavonoids could interfere with the reaction, resulting in a different color outcome. Additionally, the concentration of tannins may not be sufficient to produce a visible blue comp.
Good day everyone. Today I will discuss to you the copper sulfate test. Its principle: it is a chemical test that can be used to see if the sample has peptide bonds or not. As a result, the copper sulfate test may be used to figure out how much protein is in the sample. In this test, the presence of peptides induces the copper-2 ion to form a pale purple or mauve coordination complex. The samples in this is the guava and the sample X malunggay with the expected result of pale purple solution. As for the actual result, the guava has a dark brown coloration and the malunggay has a dark green coloration. In conclusion, the two samples did not have a positive result in the copper sulfate solution. The guava sample's result depends on the amount of concentration of proteins extracted from the sample. The extract of sample X also has varying factors such as plant natural dye that affects the color of the solution. Tannin also is negative on this test for it does not contain protein. That is all. Thank you for listening.
Good day everyone. Today I will be discussing the result that we have obtained from experiment 11 gelatin test. The gelatin test is a common qualitative use to detect the presence of tannins in a substance. Tannins are polyphenolic compounds found in various plants, particularly in bark, leaves, and fruits. When the test sample suspected to contain tannins, it is added to the gelatin solution. Any present tannins interact with the protein molecules of gelatin, forming insoluble complexes. These interactions disrupt the stability of the gelatin solution, resulting in the formation of a visible precipitate. The expected results in a gelatin test are the formation of a white, buff-colored precipitate. However, the actual result for guava are a yellow solution with white precipitate, and for our sample X, which is Moringa oleifera leaf extract, a brown solution was observed. In conclusion, the tannin test utilizing gelatin solution is a valuable tool for detecting the presence of tannins in a solution. The anticipated outcome of this test is the formation of a white puff precipitate, which indicates the presence of tannins in the tested solution. The actual results of the test on guava extract showed a yellow solution with white precipitates, which affirms the existence of tannins following complexes with gelatin. However, the Moringa oleifera leaf extract did not form a white puff precipitate, indicating a negative result, suggesting either low levels or the absence of tannin in this sample.
The gold bitter skin test is a chemical test used to assess the tanning properties of a compound. Gold bitter skin is soaked in 2% hydrochloric acid, washed with distilled water, and then placed in a tannin solution for a few minutes. Then washed with distilled water again. The presence of tannin is indicated when the gold bitter skin turns brown to black coloration. Both guava bark and leaves yields a positive result, which is a brownish-black coloration in the intestine, indicating the presence of tannins. Same goes to Moringa oleifera extract, which also yields a positive result and then form a compound of ferric tannate. The brownish-black coloration in the pig intestine is due to the interaction of iron in the intestine tissue, causing the color to change. Ferrous sulfate acts as a developer. When tannins from the test bind to the iron ions in the ferrous sulfate solution, a brownish-black colored complex forms, which signifies the presence of tannins.
Phenazone test is used as an identification test for tannins. Principle behind phenazone test is that in 5 milliliters of aqueous solution of a tannin-containing sample, 0.5 grams of sodium acid phosphate is then added. The solution is warmed, cooled, and then filtered. And then 2% phenazone solution is added to the filtrate. All tannins are precipitated as bulky colored precipitate. We have the samples of guava and the plant of interest, malunggay. The expected result is a bulky colored precipitate. However, since the test is not conducted in the laboratory, the theoretical results are based on research. Since Oncidium guajava leaves and Moringa oleifera contain tannins, both plant samples will theoretically yield a positive result.